This is addition and subtraction with regrouping using expanded form. This is a skill that's taught in second grade because by second grade they don't have they aren't taught the traditional algorithm yet. That's saved until third grade. When we use expanded notation, students should be familiar with this because we worked on writing numbers in expanded notation starting from the beginning of the year. But to give you an example, 356 would be 350. 6, and 248 would be 248. When students look at this, they look at 6 ones and 8 ones, and they know that that is 14 ones. When they look at 14 ones, at this point they should be able to see that that is a 10 and a 4. This 10 gets regrouped to our tens place, but the 4 stays in the ones place. And this shows this is getting them ready for the traditional algorithm. But instead of just putting a 1 here and students not having a full grasp of place value, this 10 is a 10. And that's the importance of using this expanded notation. When we look at 40 and 50 and we add those together, 40 and 50 is 90, 10 more would be 100. And again, that should be very easy for students to see, oh, 100, we can't have that in the tens place. We need to regroup. We regroup the 100 into the hundreds place, which means that we have 0 tens. We now have 300 plus 200 is 500, and the 100 that we regrouped is 600. So now we should be able to find our sum. If we look, we have 600, 0 tens, and 4 ones. So the sum would be 604. Looking at subtraction in expanded form, this is something that kids struggle with because of the addition signs that are intermixed with the expanded form. So there's 432. 265. But we are in fact subtracting. So that's the biggest thing to draw to kids' attention, that these addition signs right here, they are part of the expanded form, not the operation that they are actually performing. This is the symbol that tells you what to do with the numbers. As we're looking at this, we go to the ones place. We have 5 ones that we need to take away from 2 ones. Well, we can't do that. A common mistake that kids make is they try and just reverse the numbers and subtract up the problem. And we talk about that. That's why we use the base 10 models first, so that they can see that there is in fact not enough to subtract. We know that we need to regroup a 10. We take the 10 from the tens place, which leaves us 20, 2 tens. When we regroup those, that 10 comes over and is actually 10 and 2 more, which would be 12. I can take 5 away from 12 now, and when I do that, I use my strategy. Hopefully at second grade, this is a mental math, 12, and we take away 5, and we have 7. Now we move to our tens place. We have 2 tens, take away 6 tens. Again, we do not have enough tens to subtract. So we're going to subtract, or we're going to regroup from the hundreds place, which will give us 3 hundreds. We'll bring the 100 to the tens place, which we've talked to the students is actually 10 tens. So we have 120, and we're going to take away 60. When we do that, we will have 60 left. We now have 300, take away 200, we have 100. So our answer is 167. This is a good time also to talk to students about checking their work. You can check addition with subtraction and subtraction with addition. So you can take 265 and you would add your difference, and you should end up with your top number. So 5 and 7 more would be 2. And again, this is not the correct checking for second grade. You would want to break it apart into this expanded form again. But these videos are made more for parents to understand what the students are being asked to do. This is what we consider the traditional algorithm, which is not expected to be mastered until third grade. So we have 6 and 6, which would be 12, and one more 10 would be 13 tens. Regroup the 100, 2, 3, 4, 432. We have a match so that we know our answer is correct. And again, this is what we would be considering as the traditional algorithm. And the problem with teaching second graders this before they have the conceptual understanding is most second graders consider this to be a 1 instead of actually understanding that it is a 110. And this is actually 100. So it's very important that we teach them the base 10 model and this expanded form model before we get into the traditional algorithm.